Hi, this is an optional homework for people who want to program our sorting algorithms together along with me. I apologize that the sound quality is bad. I don't have my nice microphone here at school today. Even if you already wrote working versions of these algorithms, you might want to follow along anyway to take advantage of some of the nice IntelliJ features and to kind of see the intention-driven programming practice that I have. So I've created a sorting algorithms project, and you should do that as well. And then under source, I'll create a new class, which I'll call sorting algorithms. I'll type public static void main, PSVM, enter, and that will create my main method. And I'm going to start by creating a couple of test arrays and then using the methods that I'm going to create in just a second. So let's create test1, and it'll be a relatively short array. And then let's do this. Sorry, I'm going to illustrate intention-driven programming all the way through, so I might change my mind. So actually, instead of generating test arrays this way, I'd like to get random array, and the size is going to be 5, and then let's say test2 equals get random array, and the size is going to be 100. And I guess maybe I'll include a min and a max value. So a min and a max value. Okay, so I guess let's go ahead and write get random array. So the purpose of this method is going to be create and return a random array. And then it's generated very poorly chosen names here, so I'll call this length. I'll call this minval and maxval. And then here's maxval. You might be noticing that as I change the names of the parameters here, this is new for you inside IntelliJ. Instead of guessing at what these numbers are, IntelliJ actually fills in the name of the parameter that 5 is going to get assigned to right here in the method call. So that's really nice because you don't have to guess anymore. Now you can just look and see. Okay, and now these are all wrong, of course. So I'll just say length, and then here I'll say minval and maxval. I'm going to actually leave all these blank for the moment. So let's create a return array. I'll just call it R. New int, and the length is going to be length. And then, instead of typing a for loop, let's type itar to iterate over it. So now I'm iterating over the whole array. And I'm going to say array element I gets math.random times maxval minus minval plus 1. And then let's cast that to be an int. Okay. And then I'm going to return the array. Great, so get random array. Now let's create the two methods that I'm interested in. So sorted one equals, I'm going to bubble sort test1, and then sorted 2 is going to be selection sort test1. And then let's print them. So arrays, dot toString, and then sorted 1. So as I'm typing here, I'm taking advantage of hitting the tab key a lot to do the auto-completing. And this is something that you should explicitly practice at your house because it takes a little while to get used to. But once you get good at it, it will instantly speed up all of your typing. Okay, so I guess let's print both of them. Oops. Here's sorted 2. All right, so let's go ahead and create bubble sort. So let's remember how bubble sort works. The idea of bubble sort is I'm going to repeatedly do something over and over again while the array is out of order. And what I'm doing over and over again is I'm going to traverse the array, swapping adjacent elements that are out of order. And how will I know if the array is back in order? Well, one thing I can do is, while I'm doing this traversal of the array, if I ever do a swap, then I can add to a counter. And if I didn't add to the counter, if I got through the whole array and I never made a swap, then I know that the array must have been in order. So instead of saying while the array is out of order, I can say while the number of swaps made is greater than 0. Because if I made any swaps, that meant it wasn't in order yet, and so I should go back and I should keep going. So as soon as the number of swaps is equal to 0, that was a sign that that my array is already in order. Okay, so that's my pseudocode. So let's do it. So I'll type do, and then that's open that, and so I'll say while num swaps is bigger than 0. So that means I got to create num swaps. All right, so let's create it. So I'm going to create a local variable called num swaps, which I'll initialize to 0. That's fine. And now, oops. And now here I'll say num swaps equals traverse array, or like do one swap traversal. And what do I need to give it as input? So as input, I'm going to give it the array that I'm traversing. And I think that's it. So this is a method I haven't written yet, but this method is going to loop through my array once, swap everything that's out of order, and count how many times it swapped and return that number. So number of swaps that got swapped is going to return here, and now I got the while loop. All right, so far so good. I guess at the end, let's return test1. So now I'll implement this method. So I'm going to do one traversal. So I'm going to iterate the array by typing itar. And now I want to test adjacent elements. So I'll say if test1 I, let's see, they're going to be, I want to sort from smaller numbers to larger numbers. So I'm thinking, should I have it be less than or greater than? I'm testing for if they're out of order. So I'm going to test to see, so if they're in order, this should be smaller than that. So if they're out of order, it should be the other way around. The lower location number should have a larger number if they're out of order. All right, so if that's true, then I'll perform the swap. What am I going to swap? I'm going to swap I and I plus 1 in the test1 array. And again, see the method that I'm using here is I create methods as I need them. So let's create swap. I'll have temp get test1 I. Let's call this I and j as the two locations that I'm swapping. And now, oops. And now test1 I equals test1 j, and then test1 j equals temp. Okay, I'm not real thrilled with this test1 name. That seems so arbitrary. Let's change it. I forget how to rename a command, so I'm going to look it up. I did Control-Shift-A. I'm typing rename. So it looks like Shift F6. So I'm going to hit Shift and then F6, and I'm just going to call this R. And then same thing here. I'm going to hit Shift F6, and I'm going to call that R and hit Enter. And then same thing here. I'm going to hit Shift and then F6, and I'm going to type R and hit Enter. Okay. So this is performing the swap. Yep, that looks good. All right, so let's go back to the traversal. So I'm checking each array element and the one that's larger, and I'm swapping them if they're out of order. And then at the end, I need a counter. So num swaps equals 0, and if I've swapped, then notice how I didn't type num swaps, I typed nu tab, so num swaps plus plus, and then at the end I'm going to return num swaps. So again, R tab and then N tab. Okay. So now I'm stepping back into bubble sort. So I did one traversal, I counted the swaps. I'm going to keep doing that as long as the number of swaps is greater than 0, and then I return the array at the end. Okay, cool. So I think I'm done. I'm going to comment this out, and let's run it. I left a bug in there on purpose, and hopefully we'll get a chance to see it in just a minute. Okay, so I can run it by clicking this green arrow, and it's running. And it says array index out of bounds 5. So that means that I'm trying to access location 5, but location 5 is outside the boundaries of my array. It's probably too big. So we can click here because this is the line that it's happening on. So I know that this line is going out of bounds for some reason. That might be enough for you to just fix it just by looking at that line and seeing. If it's not enough for you to fix it, then the next step would be you could debug by adding a breakpoint here and running the debugger. What I'm thinking is, okay, so I goes all the way to the last valid index. But then I look not only at I, but I also look at the location after I. So actually, I can't have I go as large as the last element in the list, because then I check one location past the last element. So I'm going to have it, so I'm going to subtract 1 from the boundary where I'm going to have it stop. So that way it doesn't actually, so I never visits the last element, but instead we're still checking that last pair. Okay, let's try it again. Great. So I didn't print out what the array was before we sorted it, but this is certainly in sorted order. All right, rather than look at that more deeply, let's go ahead and implement selection sort in the same way. So I'll hit Alt-Enter, create method. I'm going to rename test1 to just R because I think that's a more generic name. Oops. Right away, I'm going to say return R here so that there are no compile time errors when I start my programming. And let's think about the pseudocode. So for selection sort, I'm going to loop starting location from 0 to the end of the array. And then I'm going to find the smallest value in the array starting at the starting location. And then I'm going to swap the smallest value in the array with value at starting location. So when the starting location is 0, I find the smallest value in the whole array starting at 0, and I swap that smallest value into the 0 index. Then starting location goes up by 1. I'm at index 1. I find the smallest value in the array starting at location 1. And then once I've found it, I swap it into location 1. So over and over again, I'm swapping the next smallest number into the front of the array where it needs to end up. Okay, so let's do it. So I'll have a for loop. So I'll say for starting location equals 0, and then notice I'm not typing the full name. I just do st tab. So starting location is less than array.length. Starting location plus plus. So I want to find the smallest value in the array. But I'm thinking, actually, I don't want to find the smallest value in the array. What I really want to do is I want to find the location where the smallest value is, because I'm going to need to swap that location with my starting location. So I'm going to say smallest location equals find location of min starting at, and then starting location. So this method is going to start at this location, and it's going to search forward in the array. So actually, I guess I need to give it the array. So it's going to search forward in this array, starting at this location. When it finds the smallest element in the whole list, we're going to return the location where that smallest element was, which gets saved here. And then I can say swap, and I've already written my swap. Only this time I'm going to swap starting location and smallest location. And there's array R. Okay. So that's my full code there. So now I just need to do this one, which finds the minimum. And that's a pattern that we'd seen in the summer homework. So let's do this. I'm going to type iter to iterate, but I'm not going to start at 0. Instead, I'm going to start at starting lock. So again, I'm using a lot of tab here. And I'm going to go to the end of the list. I'm going to initialize some variables. So smallest so far is going to get my array. So I'm going to initialize it with the location where I'm with the value where I'm starting my search. And if that value happens to be the smallest, great, I'll return it at the end. And if it's not the smallest, then it's going to get replaced as I go along. So now I'm going to test if the array element I is smaller than my smallest so far. And if it is, I'll save that as my new smallest so far, like this. Okay, but there's a problem, because at the end I actually don't want to return the smallest value in the array. Remember, I want to return where I found it. So I'll need another variable to remember where was that location. So so location of smallest. So when I initialize it, I'll initialize it to the starting location, because that's where my smallest so far was initialized. And now if array element I is smaller than my smallest so far, I will store where I saw it, which was at index I. So index I is the new location for the smallest thing I've seen so far. And then at the end, I'm going to return location of smallest. Okay, I think that should work. Let's just do a quick spot check here. So system.out.println. What do I want? So selection sort, so sorted to. So arrays dot toString sorted to. Okay. Let's take a quick look. Okay, so that seems like it's in sorting order. So this is so it's okay if you have your own implementations, but this is the starting point that we're going to use in class, because in class we're going to be focused on how can we record the run times of these two methods for different sized inputs. Okay, thanks for listening. I hope that this practice was helpful. You want to be driving to the point where you can kind of code as fluidly as this. Like you'll write out your pseudocode and you'll implement you'll use methods as you need them, and you can jump back and forth and you can implement them. Hopefully by the end of the year, that's where you'll be. Okay, good luck.